La nada nada, la nada nada, nada nada nada, la nada nada, la nada! Alright, guys, please excuse the poor attempt at singing there, but La Nada, that is the theme of winter 2015-2016, at least according to me here. Let's crack right into this forecast, because that's what you came here for. So, this is the current sea surface temperatures as of this recording in mid-August. You can see a nice little plume of cool air in the eastern equatorial Pacific Ocean. Glad I said that right the first time there. But you can see this little plume here. That is our La Nina happening right now. It's rather weak. It's sputtering a lot. It's not doing much. But it is affecting our weather and could affect our weather this winter. I'll get into that in a second. And then you got a warm Gulf of Alaska. This is our Pacific Decadal Oscillation, PDO. It's been warm for a couple of years, and usually when it's warm, it makes our weather in the United States colder than the average. Last year it wasn't because we had a super Godzilla El Nino, according to the media hyping it up here. But we had a pretty crazy El Nino, we'll say that. What I've noticed is lately that the PDO has actually cooled a little bit. It's going to be a trend to watch. Some people actually think it's going to go negative this winter. It would have to cool quite a bit to do that, but it's going to be a close call, and I think that will be the big thing that if it changes, it will change the forecast in October when we release our final one. Here's a little zoomed in view of the La Nina. Nice little plume of cool air down there. Nothing terrible. It's only about a degree average, below average, to maybe 0.5. So it's a borderline La Nina. This is the ENSO for the past about 2 years. You can see that big old El Nino in the middle of 2015 into the winter of 2016 and 2015. And that really decreased throughout the spring and early summer. Now, as we get into July and August and September here, it's really leveled out, and it's stayed as a weak La Nina. Here's a zoomed-in view of this. This is in our Nino 3.4 quadrant. You can see that really since July, it's been below average sea surface temperatures, especially around now. And so we are in a La Nina right now. This is our PDO, and you can see, man, it's been positive since probably January 2014 for the most part. And it's been very positive since then. And this has affected our weather and will continue to. Now, the question is, will it stay positive? I think it will. Some others don't think it will. We'll see what happens. This is our computer models. This is a little graph of a lot of the different computer models plotted onto a graph. And this goes out through, I believe, actually goes past 2017. So our winter, it's actually forecasting, most of the models are forecasting 0.5 to about a degree below average. Boy, I don't know. I mean, there's quite a few at that 0.5, maybe even several above the 0.5 degree mark below average, which would indicate a La Nada or a very borderline La Nina. So I don't think the La Nina, if it occurs, is going to be overly strong, and it's going to not really impact the weather too much. I think we're going to be closer to a La Nada, just a neutral winter, that is. Here's a typical pattern for El Nino and La Nina. El Nino, your jet stream, your polar jet stream is diverted way to the north. You get a lot of warm air in the northern United States, and then you get some wet conditions in the southern United States. Usually end up dry in the Ohio Valley. And last winter, it was kind of like that, except the southern U.S., southwestern U.S. wasn't all that wet. The central and southeastern, southern U.S. was pretty wet last winter, especially the central. The central U.S. was a lot more wet than average. It ended up, I think, pretty dry out there in the Ohio Valley, but it was for sure warm in the northern U.S. And in fact, much of the U.S. was warmer than average last winter. But our focus shifts to good old La Nina here, where you get a blocking high pressure out in the Gulf of Alaska. The jet stream gets diverted to the south, and a lot of cold air comes with it for the northern, central, and eastern United States. This brings clippers, and it pulls up lows from the southwest and really hammers the Ohio Valley and sometimes the east coast of the United States, usually, with warm and dry conditions under that. But I think it'll be a little bit different than what that shows. These are some of the analogs that I think this year will play out. We've got 1958, 1959, 83, 84, 85, 86, 13, 14, and 14, 15. That's how this winter could end up, with a warm western United States and a colder than average, pretty much all of everything east of the Rockies cooler than average, with the exception of the southeastern United States. That looks pretty good. So putting this whole shebang together, we've got colder than average temperatures east of the Rockies, brutal cold up in the northern United States out to the Ohio Valley, warmer and drier than average in the southwestern United States. You're going to have some moist and average to slightly above average temperatures in the northwestern United States. Could get a little more snow than average up there. And you're going to get a cold and snowy central and eastern United States with our winter jackpot, our winter jackpot 2000, if you will. That's going to be the Ohio Valley. They're going to score this year a lot, in my opinion. And parts of the inland parts of the northeastern United States. I think as you get towards the coast, the snow amounts and the cold weather is going to drop off significantly. But I still think it's going to remain below average temperatures and above average precipitation for much of the northeastern United States. Here's how temperatures look. Warmer than average, west coast, southwestern United States especially. Below average for much of the areas east of the Rockies except the southeastern United States. Much below average in the Ohio Valley. Precipitation, snowfall, above average, northwestern United States. Below average for much of the southern third of the United States. And above average snowfall and precipitation from the central U.S. to the Ohio Valley up to the northeastern United States, with the Ohio Valley scoring big this winter. You're going to get clippers that ride down into the northern plains and in the Ohio Valley, and you're also going to get southwest lows that I think are going to consistently track through Oklahoma, out to the middle Tennessee Valley, and maybe even up into the northeast. And I think there's going to be some nor'easters this year. But I think most of the snow will be inland northeastern United States out to the Ohio Valley. So that concludes the old winter forecast 2016-2017. This is a preliminary forecast, so use this information responsibly, but don't be afraid to share it. Now you're probably wondering, why did I release this so early? Well, there's a few different reasons. Number one, since you're probably a friend of mine on YouTube or Facebook or whatever, you get inside access, okay? So I'm going to lay it out how it is. I'm going to tell you when stuff looks to be happening, where it's going to be happening. I'm going to release it earlier. I'm not the news, so you guys get stuff early with me. Now, the other reason is because I'm actually releasing my super winter forecast on October 25th. And with that, you get regional updates, you get more detailed analysis, and an updated version of the winter forecast. There's also going to be a bonus tutorial called what I'm going to call my winter forecasting playbook. Okay, and you're going to be able to use this little tutorial and predict winter storms, even if you're a total beginner. Okay, you're going to be able to know where winter storm is going to be. I made this very easy, very simple, and you can learn it under a half hour. So with those two things, how do you get them? Well, hey, go below this video and find the link. Enter your region, enter your email, tell me where to send it, and I will send it to you on October 25th, 2016. My official winter forecast won't be out till November 1st, and it won't include the tutorial and won't include the old regional views. But because you're my friend, I'll send it to you. And I'll send you some updates on that. So you'll be able to plan a week ahead, because it could be snowing already in early November. You'll be able to plan a week ahead, and you'll be able to get your forecasting game to the next level. But just do me a favor and don't abuse this newly found forecasting powers to freak people out with your weather models and stuff. But this is just tools in your toolbox you can use to help your weather forecasting knowledge grow. And so go ahead and go below, enter your email, and enter your region. Tell me where to send it. And also, if you haven't already, subscribe to my YouTube channel. I'll be posting more updates and forecasting tutorials on this channel. And follow me below on Facebook if you haven't already. I post some more updates on there as well. So go ahead and sign up. Follow me on YouTube, follow me on Facebook, and I'll see you soon.
Good evening, everyone. I am WeatherWorks meteorologist Brad Miller. Joining me tonight is meteorologist Brian Marmo, and we are talking winter weather, Brian. Hard to believe it's still hot out there, but Brian is our long-range weather expert here at WeatherWorks. And again, we do have some differences we're already seeing, even though it's late summer versus last year at this time, where we may see a little bit of a different winter pattern setting up, correct?
Yeah, so one of the big things we can look at this early on, of course it's still only the end of August, is sea surface temperatures, and especially out in the Pacific Ocean. So we're kind of looking at two areas right now. One, we have the tropical Pacific, where we see cooler than normal, where we see those blues, the cooler than normal sea surface temperatures. And then also we're looking at this Gulf of Alaska right here, the two, where we see some warmer than average.
Right now, last year this time, we were seeing an abundance of above normal temperatures in the Pacific equator region. This year, we're seeing a bit of an opposite. What does that mean?
Yeah, so last year we had one of the strongest El Niños on record, really one of the dominant driving forces. Mm-hmm. But this year, El Niño is now dissipated, and we're now watching the potential transition to a La Niña. So that's really going to be one of the drivers. And El Niño is the warmer phase of ENSO, and La Niña, the one we're potentially watching the transition to, is the cooler phase of ENSO, or the El Niño Southern Oscillation.
And we had El Niño last winter. We saw the result of it. It was a very mild winter for much of the Northeast, even into Mid-Atlantic, into the Midwest as well. Really didn't get cold until January, really. But then we, of course, had the one blizzard. But other than that, it was a pretty mild winter. But this winter may be a little bit different with this La Niña now setting up.
Yeah, so that's going to be one of the things we're going to watch over the next couple of months, is a potential transition into the La Niña phase.
And then as we take a look also, we stay out in the Pacific, and one of the driving factors changing from El Niño to La Niña is what we call the PDO, the Pacific Decadal Oscillation. What is that exactly?
Yeah, so this is more of where ENSO looks at the tropical Pacific. This is more of the northern Pacific, where we're looking specifically the Gulf of Alaska down the west coast of North America. So there's the PDO has two phases similar to ENSO. There's this warm phase, and this image is representative of that, where we see this warmth over there, and also a cooler phase. We've actually been in the positive phase now, and this is something really we've been watching and talking about for the last couple of years. We've been in the positive phase of the PDO now since January of 2014.
And as we do transition into fall and into winter, we're going to probably see, like you said, the La Niña, but what's uncommon is a positive Pacific Decadal Oscillation combined with a La Niña. You don't see that all that often. So what does that exactly mean? How is that going to kind of play out?
Yeah, so that's going to be one of the things we're watching. Of course, we have the sea surface temperature anomalies, what they are now. Of course, we have to look at what they're going to be during the winter. So here's a CFS modeled of the sea surface temperatures during meteorological winter, and that would be December, January, and February. And we still see these two signals. We see this cooler tongue going out from South America across the tropical Pacific, and then we also still have these warmer anomalies off the west coast of North America.
Right, and these were here last year. The big difference was right here in the Pacific equator region, where we're going to see those below normal sea surface temperatures. And I probably got a little bit ahead of myself there. So again, when we see that positive PDO and a La Niña, again, that's a little bit uncommon, and that's going to trend towards what we may see a La Niña pattern setting up over the U.S. versus what we had last year with the El Niño.
Yeah, and interesting enough, ENSO is one of the driving forces behind the PDO. And as you were saying, a La Niña is generally correlated with a negative PDO. While it's not unprecedented, we have seen it in the past, but it's relatively uncommon to see the positive PDO with the La Niña, especially because we only really have solid records going back to about 1950.
Right, and we, again, look at some of the past winters, sometimes what we call analog years, when we see maybe a trend that's setting up now, and we'll go back and say, well, maybe it looked like this winter, maybe it looked like this winter. And there are some winters that are starting to look a little bit like what we could see, correct? But it may be a little too early still to forecast that.
Yeah, so we have seen this pattern before. One year that comes to mind is 1983-84. It was the winter following the very strong El Nino of 1982-83. And it was kind of this similar transition to this weak La Nina, but you still had that PDO signal along the west coast. So, of course, they're not carbon copies of each other, but it's certainly something we can look back at and say, okay, maybe that's going to give us an idea of what to expect.
Right. And again, we had El Nino last year. We saw the result. Trending maybe towards an El Nino this year, and this is something that looks completely different from last winter. So explain what we're talking about here with the jet stream pattern and why we're seeing maybe below normal temperatures for much of the U.S.
Yeah, so last year, most of the eastern half of the country, especially early on, was dominated by upper-level ridging, which allowed this warm air to surge up from the south up into the Midwest and the East Coast. So what we're looking at here on these positive PDO La Nina winters, we see this ridge of high pressure out west, which promotes more dry and warmth, especially in southern California. But then on the eastern part of the country, we see this trough of low pressure, which allows the colder air to funnel down from the Arctic region into the northern plains, the Midwest, and eventually to the East Coast.
Right, and then when we're talking about these below normal temperatures in the Midwest and even into the Northeast and New England, what that would tell me as a meteorologist is that the northern branch may be a little bit stronger than the southern branch, which in turn may mean more clipper systems, more kind of nuisance snows.
Yeah, so last year was, for the East Coast specifically, was dominated by that big storm where a lot of locations saw record snowfall.
Blizzard in January, correct?
Exactly, but we didn't see too much other than that.
Right.
It was, as we've said before, it was dominated by more warmth, warmer than average temperatures. So this would be a completely different pattern where it would be colder than normal, but quite active in terms of snow. You'd see a lot of more smaller, medium term.
It doesn't mean that we
events.
can't get the typical coastal system, either a classic nor'easter, because you just got to get the phasing correct. It will happen, I'm sure, once or twice, maybe more. Again, but this pattern would still tell us that it would be more of those clipper systems versus a coastal system. But again, we can't rule anything out this moment, especially in late August.
Certainly, yeah, we're not ruling anything out at this time, but certainly something to keep an eye on.
Right. And again, this is just our first winter outlook. We're going to have several more as we get towards winter itself. Again, there's a few other factors. Explain what we're talking about here.
Yeah, so we're looking at mainly we've been looking at the Pacific Ocean as one of the major drivers, but there are certainly other things to look at.
I noticed the Arctic Oscillation. That sounds a little bit more for the U.S.
Yeah, so the Arctic Oscillation is more of the more in the Atlantic. It actually has a greater correlation with weather during the winter on the East Coast, and so does. That's more of a West Coast. Obviously, it does impact our winter, but the Arctic Oscillation has the strongest correlation for folks on the East Coast in terms of cold and snowy, and that would be the negative phase. So that's it's a little bit too early to speculate on that. That's something we get a better feel for as we get into October and November.
But it is safe to say, though, we're thinking that this upcoming winter will be colder than last winter. Snow-wise, we're still kind of see how things play out and what the trends may look like, but probably not going to be as mild as last winter.
Oh, certainly not, yeah.
All right, and again, that's our first stab at our winter outlook right here at WeatherWorks, and we'll have several more as we get into our fall months. Don't forget, you can follow us on all of our platforms. On social media, of course, you got Facebook, WeatherWorks, Twitter at WeatherWorks, that's our handle. Got Snapchat and Instagram, WeatherWorks LLC. And don't forget, we are here to service you during the winter season as well. Visit our website, weatherworksinc.com, and there's always plenty of stuff on there for you to enjoy. And you can view our storm alert forecasts. If you become a client, our very popular heads up notification, and our nation's leading snow and ice verification service, which is called Certified Snowfall Totals. All this, again, is accessible at our website at weatherworksinc.com, or just call us. And there's always a meteorologist on staff 24 hours a day. Again, we thank you for joining us right here on our first look at the weather and the winter outlook of 2016, 2017. Brian, thank you very much for joining us, and we'll see you back here again some other time.
Well, I'd like to welcome everyone to the 2016-2017 Winter Question and Answer Forum, sponsored by Schoenberg Salt and Weatherbell.com. With me today is meteorologist Joe Bistardi. Joe Bistardi is currently the chief forecaster at Weatherbell.com, formerly the chief long-range forecaster at AccuWeather. Joe is an institution in the science of weather prediction. Many companies across the multitude of industries, from energy to retail, have profited from his forecasts. His exceptional skills are rooted in a comprehensive understanding of global oscillations and in-depth analysis of historical weather patterns. His analog approach, which finds similarities between current and historical weather patterns, allows him to make an accurate forecast, sometimes in defiance of computer model consensus. Joe's also well known for his blog featuring the popular videos The Atmospheric Avenger and The Raging Weather Ball, which can be found on weatherbell.com. His reputation for making bold and accurate forecasts has landed him on major television programs, including Fox News Live, ABC World News, The O'Reilly Factor, The Colbert Report, CBS's Early Show, Imus in the Morning, and several others. And Joe, I welcome you. Good afternoon.
Well, good afternoon. Thank you for having me.
So, Joe, what I want to do today is just basically ask some basic questions that people in my industry, people praying for snow and ice, are looking for answers or some sort of guidance towards this upcoming season. So the first question is, now that we're into August, the question on everyone's mind is, what type of winter can we expect in the Mid-Atlantic and the Northeast?
Well, I think the last 2 winters in a row, we've gotten off to a very warm start, and we're concerned about that. In fact, 3 of the last 4 winters, 2012, was also off to a warm start. And then we saw the main part of winter was January, February, and March. We think we have a chance at that again, a warm start, but the January, February, March, as opposed to last year where we had we had the real big storm, and anything that was going to fall was either going to be a lot of snow or not much snow at all because of the way the storm tracks were. We think you're looking at many more events, individuals, and perhaps smaller events, of course, but also more widespread cold, January, February, March, more along the lines of what we saw in the winters of 12, 13, 13, 14, 14, 15. And so that January, February, March period looks to be the part of the winter to really hone in on. If we get December, it'll be a bonus, and if we get December, it would be as if we have a chance to have the same kind of things that we had a couple of years ago, even without December. New Jersey, the state of New Jersey, running out of salt.
Now, Joe, you talk a lot about solar activity, and I know it's very low at this point in time. And how does that affect even like a La Nina or just the weather in general for this season?
I talk a lot about solar activity and sort of trying to counter a lot of the ideas that I see out there. Like there's a little ice age coming and all that. I believe it has some effect. Most notably, for instance, if you understand that the decrease in radiation, you would say, well, okay, that's going to make it colder. Well, not if the oceans are releasing heat in the atmosphere. A decrease in solar radiation over the equatorial areas would tend to negate La Ninas. Why? Because if the easterlies are not as strong there, you don't get cold water upwelling, so you build warm water up. So that would instantly say, oh my gosh, that means an El Nino is coming. Well, what it may mean is a weaker La Nina in this particular case. It does lead to more blocking. There's a relationship between the strength of the geomagnetic field and blocking, but the question is, where does the blocking develop? For instance, there's been plenty of blocking the last 3 years. There's going to be plenty of blocking again this year. If you get the right kind of blocking, it extends centered over Greenland back to Western North America. It's a bonanza for both Europe and the Eastern United States. You just get it over the northwestern part of the United States, so northwestern part of North America over the pole. It's generally over the eastern part of the United States. But what winter we had, and the reason it wasn't 97, 98, which a lot of the people that we compete with were trying to, that was a snowless winter on the eastern seaboard, for goodness sakes. We're trying to portray it as 97, 98, because there's so much blocking and that ring of warmth. I'm not, people talk about it, but the ring of warmth in the Pacific also adds heat, which also helps the blocking. So when you're talking about those things, you can't focus too much on one thing. There's something called the quasi-biennial oscillation, which is shifting to more easterly, which favors more blocking. What we do is we have something called the Weather Bell Pioneer Model. No one else has it because Joe DeLeo developed it. So Joe DeLeo is not sharing it. So what happens is that Pioneer Model takes into account the strength of the solar, the quasi-biennial oscillation, all the 23 different variables that are piled in there, and then comes up with a forecasted 500 millibar and temperature analog, and then we go from there. So it has something to do with it. I just would stress to people that you have to look at the big picture. There's no magic bullets in this thing. There's no, this is it, and that's it. It's trying to get a matter of all the things that are involved, and then you have to try to weight them. If you weight one too strong and another one not strong enough, then you have a problem. So the amount that the solar contributes is always in question, but does help out with blocking.
Now, I know that you talked about December being kind of a month where it could go either way. As far as
we think right now it's still biased warm, but one of our analogs is 95, 96, which of course was not warm in December. So when we're looking at this, when we're studying this whole situation, we want people to understand that we do believe that at this time, but we're very fluid in that particular month right now, as there is sentiment that it could be colder than what we have.
What do you look for to determine? I mean, what are you going to be looking for over the next few months as we get closer to December to determine?
We have to hone in on the amount of cold we start. I mean, it's a matter of, okay, so suppose you're driving from one point to another, and that you have 2 or 3 roads you could take, but you don't know which one to take based on where there's going to be a lot of snow on the road or something like that. It's from snow squall. Let's say you're driving through Pennsylvania. So what happens is you get closer, you have to figure out which exit you want to take and that type of thing. I mean, you know that you're going to get to a certain destination, and you'll arrive there. So, I wish I could tell you what the answer is, and that, I think that you got to understand the saddle months where you're shifting season and the jets changing means that the atmosphere is feeding back differently every week. So
I know the Western Atlantic is very warm, much more so than normal, correct?
And that's,
how's that influence the upcoming winter?
Well, that's what I was saying before. It's your foe early, your friend later, because what happens is if there's not a lot of cold air available early, then the warm air just overwhelms everything. So what you have is you have an Atlantic that's pumping heat into the atmosphere, and you're seeing it go on right now. All right, and the Atlantic is so warm that it's dumbing down how cool the air masses can get when they get to the eastern part of the United States. People go, oh my gosh, it's a hot summer. No joke. Post-Nino summers when the Atlantic is this warm are going to be hot and humid, and you see it so dry in New England, and that's part of the process too. By the way, you watch this turn around over the next 3-4 weeks and on into fall in the Northeast, because what will happen is it starts raining there because of all that moisture in there. There's a release of latent heat in the atmosphere and turn pumps the ridge, so that you have what we call endless summer setup. And the endless summer loves to run deep into the fall and even into the early winter.
So just to sum up then, I know you've put out your preliminary forecast on the Weather Bell site. I mean, basically your feeling is January to March is really going to be